I think people are forgetting there's this one standard thing you often do in science, or at least sometimes. You know, if you want to prove something that's essentially impossible to prove, you assume the opposite, or you assume the thing and then you follow it. So you assume there are intelligent extraterrestrials that we could detect, and that's what we're doing. And this is applied all through science and much more mundane things. You assume there's a positron, or even if you think there's not, and you hunt for it and don't find it.
I think one of the things we could talk about is what kind of measure do we really need to determine how no the no is. And one that I've heard discussed is detection of an Earth like, let's make it a 1960 Earth with the transmissions and television broadcasts and FM and whatnot, radars. At what distance? How close do they have to be? And right now, and the corresponding question is, what is the number of intelligent transmitting species in our galaxy? And right now, in spite of the 20 or 30 years proving that we can't possibly find anyone that we heard this morning or this afternoon, the answer is they've got to be a lot closer than the nearest star, given the technology that we've had so far. And I think what we're seeing is that each generation takes on a kind of moral responsibility to do the very, very best they can with whatever funds they can raise to make that distance further. And each year, each decade, each century, we can find how we're doing. What is the minimum number of civilizations? What is the average spacing? And if we can set a goal that a century from now we'll only need 1 billion civilizations, that's a worthy goal. And that's a kind of different way of looking at the question of how do we know how no it is. Might toss that open for discussion sometime.
It's exactly the way to get papers published in the peer-reviewed journals, because it's a way you can phrase it. You're looking for however you want to cast an upper or lower limit. And there are any number of papers published on other topics. Here's a plausible physical mechanism, and we went looking, and we didn't see anything at this level.
Right.
But of course, there's this model down here, and if we get another order of magnitude, we'll be good.
Gravity waves.
Release that.
Yeah.
Following up though on this topic of sort of cathedrals, and I'm glad that Jill is in the audience or in the room here. As part of this meeting, I actually started to look back. What was the history of looking for brown dwarfs? And for the non-astronomers, brown dwarfs are essentially failed stars. So they're blobs of hydrogen that cannot support thermonuclear fusion in their centers. And my understanding is that the first suggestion of such substellar objects occurred in the early 60s. It was in part to solve a missing matter or missing mass question at the time. And the first real convincing evidence, I think widely accepted by the community for the existence of these things, was in the sort of early to mid 90s. So call it 30 years. And on that time scale, it's like, yeah, we'd be looking for, generously 50 years. Big deal.
The neutrino proposed 1932, detected, I think, 1956.
There are any number of these examples, yeah.
Neutron stars.
Yeah.
Well, but that may be a dangerous one, because the trouble with brown dwarfs in particular was there were a lot of false announcements to the point where people, you were really, really hesitant to publish evidence for a brown dwarf because too many people have been burned too often. Likewise, looking for organic materials in a meteorite, that there are so many false negatives, which is interesting that that's not happened in the SETI case. I can't think of any really embarrassing false positive that was presented as evidence of extraterrestrial life in these 50 years.
Wow signal.
Yeah.
Well, but even there, they were the ones who were the first to say, this is interesting, and within, 48 hours, you kind of knew it wasn't.
Well, no, we spent thousands of hours of telescope time since then, people trying to track it down.
If you guys get a signal that is unequivocally artificial, how are you going to decode it?
You don't have to.
Yeah, who cares?
It answers the question.
Okay.
That's someone else's job.
Who else would have that job? If you get a job
We
raising,
might turn it into our job real quick.
But you can't talk
Depends on
back
what the pay was.
because it would take too long.
Doesn't matter, you've had a very fruitful conversation with Shakespeare and the early Greeks and the Romans.
But Shakespeare is a human, so were the early Greeks and Romans.
But you, I thought when you said you can't talk back, you were talking about the time.
Yeah, or, no. What you say is that, I think, I appreciate what you're saying.
If you wanted to send a message back, and I'm not sure we do, you could just repeat it back.
I thought you said you couldn't decode it.
Well, you could,
you can repeat it without decoding it.
The original question.
Okay.
put sentences.
Unequivocally something you can't decode.
Since he's not here to point out his own work, Woody Sullivan has a really nice paper pointing out how much you can infer from seeing terrestrial TV carriers without decoding any of the information. You can learn a remarkable.
Including that there's no global governance because
Yeah.
the allocations
Oh.
in the different ITU regions differ by few.
That's an easy.
Well, that could be two species with different kinds of eyes, too.
But even at its peak, that radiation leakage
It's gone.
below the microwave background by the orbit of Neptune
Yeah.
doesn't escape us.
No, the carriers are there. But-
Similarly, even if you can't decode it effectively, John Elliott in the UK has been doing a lot of interesting work on message structure and what you could infer about the intelligence or degree of complexity of the entities that we're sending in. He's been doing that by comparing the underlying structure of languages on Earth, including dolphin language. So the zip plotting the orders of entropy. Interesting work.
Another thing to think about is that in military intelligence, one may intercept signals, radio signals from the adversary, which one cannot read because they're encrypted, or maybe even they're in a different language or something. And yet, there's a whole department of the signals intelligence people who are concerned about where is the signal coming from, what frequency was it on, what times of the day does it transmit, is there the style of a person on the Morse code key that's different from another operator in someplace else, and keeping track of all this stuff about the message that they can't actually understand, but it's based on the sort of physical characteristics of things, and they can learn an awful lot about where the ships are and who's talking to whom from that kind of information. Even although in the next building over, there's a bunch of people actually trying to crack the codes and read what the messages say. But the first kind of signals intelligence is the kind of thing you were talking about. And we have an earthly analog of that problem.
It'd be a great problem to have.
Yeah. Tom?
If it's a beacon, and we can't decipher the message, doesn't that mean they're stupid?
That we've learned something.
I don't think even this is a critical issue, the one we're talking about, but I think it's not as dichotomous as that between natural and unnatural. Okay, pulsars, little green men, that's a simplistic example, but there are quasi-periodic, quasi-stochastic physical processes that I could hypothesize without venturing too far from natural astrophysics, things that in some sense could modulate light or produce something that would be intriguing, that would not be parsable in a trivial way, that would not appear to be part of our set of natural phenomena. So when we're playing that inductive game, that's tricky. It's not dichotomous. We like to think of the slam dunk and contact. We're conditioned to think of what the message will be and how rich and complex, whether we understand it or not. But I think there's a lot of gray in the boundary of physical phenomena we haven't yet experienced and understood and modeled. So, we may get some really tricky stuff.
I think questions like this will probably be addressed, at least in part, in some other events on Tuesday and Wednesday. So it's about time to wrap up and see what's for dessert. Joe, do you have?
Well, just one other aspect of Are We Alone and the entire looking for other, I was thinking back to the perspective earlier this morning on astronomy. Even if we are alone, that doesn't mean we shouldn't be afraid. Because as was pointed out, the sun is getting brighter, the earth is going to become uninhabitable at some point. So even if we are alone, we should still be afraid.
I'm so glad you pointed that out.
Right. Well, I'd like to thank everybody for